how sets, like any other data structure, till now we have seen like list and tuple. Set is a new data structure which will help us to do certain things. If you see in the first two things like list and tuple, we have noticed that we can address them by using their index, but set is slightly different. So initially, like every other, so here also we have some properties for sets that we can focus now. If you see, every sets will have this kind of operations. Okay, so we can create a sets using like this. So here the most important thing when you're creating a set is that when you have a empty list, we have created like a empty list like this, right? And similarly, if you have a empty tuple, we have created like this, empty tuple like this. And similarly, when you have an empty set, we cannot create like this. So the problem I will tell. So the same braces we use for both the purposes. So if you do like this, it is called as a dictionary. So if you have a empty set, we should create like this only. And the empty dictionary that we will learn afterwards, that we can use like this. So hope you understood what I'm trying to say. So till now, whatever you create like this with empty values means. Alternatively, these two can also be created in another way, right? Hope you remember I told you, if you want to create like list 2, we can create using a list built-in function. And similarly, we can create a tuple 2 using the tuple built-in function, right? In the same lines. So for tuple also like this. Whereas for set and dictionary, we should create like this. Even a dictionary also can be created two ways, either directly with a thing or like with a braces. Hope you understood what I'm trying to say. So when people are working with sets, the most confusing part is that the braces. We are using flower braces here. If I use a square braces, it's a list. If it is a parenthesis, you call it as a tuple. But if you are using flower braces, that's where confusion comes. It's not that difficult. When you go to the dictionaries, I will tell. Dictionaries will have like key column value like that. But in general, at this moment, you need to remember that if you want to create a set with some values, you need to create like this. So maybe like, set with values. Okay, set with values. If we have values, I can do like this. I can create. But if it is empty only, that point you need to remember. Now, one more interesting point when you're working with sets is that if you say set with values, something. Okay, so set with values, if you see, when I'm printing, I got the values, right? In this particular case, did you see how we are getting the things? In this case, it was ordered. What are you getting the values are in an ordered fashion. Say like I'm saying like set2 is equal to, I take like some numbers in some order. What are the way? After that, if I ask, hey, what is set2? Did you see what happened? The order in which you gave is not present. And also you give 4 values this time, but only 3 came. Why? So here you can observe that. So 12 is repeating, right? So when something is repeating, you can see only one occurrence. So that's a second point. They don't store the duplicates, and also sets were unordered. Means the order in which you gave the things will not be the output. So in this case, sir, how it happened means it is out of random, I would say. It's a very random case. Sometimes it happens, it may not happen. Then how do you do indexing? So can we do indexing for the sets? Is not possible. Because they were not ordered, we cannot uniquely recognize them based upon the position. Say if I do anything like this, see here. if I say set of like zeroth element or like first element, if I ask, so you will see an error called as set object is not subscriptable. This is the most important error that you can understand. For any object, if something is saying it's not subscriptable, means like we cannot index it. So index error is different, right? Index error we get when you are asking a values which are out of index, let's say in a list or a tuple or a string. But here you should not access like an index. That's a point. Of course, as indexing is not possible, obviously, so slicing is also not possible, right? So when indexing is not possible, slicing is also not possible. Uh, yeah, slicing object is not subscriptable. The same thing. Now you understood. Okay. So what is the most important use case of a set? Generally we go, whenever you have like some values, we can go with like getting the duplicates to be removed, right? Say I'm going for one example, you know, real-time example. Say I have a list. So I'm going to a particular server and I found that there were a lot of running ports which are open. So as the values are stored in a square braces, it's a list. And if you check what is the type, it's a list. So total length means total number of elements and total values means you got it. Now, if say someone asked you that, hey, I want to get the unique values, remove the duplicates in the list or a tuple of the elements. If you need to do like, say unique ports. So this is a requirement for you. If this is a requirement, what you do for each port in, so what are the running ports, right? For each port in running ports, you want to check like, if the port is already present in it or not. See, every time what I do, um, first I will check within this unique ports. If it is not there, then I will add. If it is there, then I don't add. So if each port in unique ports, then I don't do anything. Means I will do continue. Continue means what? It will not go to the next line, right? In other cases, I will do like unique ports dot append of. So what are the each port I have? So this is how I add one port at a time. And finally, if I try to print the unique ports, you can observe that. So don't you see you got the unique values among them? And that too, two things here. So unique you got, and the order is also same as input, right? Input running ports. If you want the order in which the user was given, then we should go for this kind of way. Okay, if you are not interested in the order, you are just interested in the actual values, that's it. Then you need not go all the way like this. You can define, so using like this, say unique ports 2 is equal to set of what are the running ports. Running ports is a list, right? You pass to a set built-in function, then what are the result you get is exactly same like that. So instead of you doing this much struggle and creating this, we have a data structure which is doing. Of course, this order, see here, in a tuple, sorry, in a set, order we cannot expect. Sometimes it will be exactly same like us, but don't think that it is an order. It is out of randomness. Now, did you all understand what is importance of this data structure? In real time, most of the use cases, people will go with that. Now, similarly, same like what we have done for a, these things like type, length, and the values. Here also we can ask for both the things. As it is a running port, say like I'm taking one of them. Say for this one, I can ask, hey, what is the type means? It will tell that I'm of type set. If you ask length, can we ask length of a set? Yes. So though it is storing the unique values, but it is storing values, right? It will give its length. Totally, it has three elements. Yeah. Hope you understood what it's all about. Now, going the next step. I also showed you how do you create a tuple, right? So yeah, like that. So next thing I want to say is like I will go for some small simple set. Say okay, my set is equal to something. I read like 113322, and I will put like my set. Yes, sir? So don't think that it is doing ascending order again. The order doesn't matter for us. You need not even well. And there is one more built-in function called as dir. If I do dir for any object, you will get the list of attributes. Similarly, sets also you can get the list of attributes. And if I ignore the things which have underscores on either side, so still I have a lot of things. So set is also like a very interesting thing. So first and foremost, as we have discussed with things which have underscores on either side earlier, in the same lines we can do them here also. So using in operator, underscore contains, or like you can do with so two in your set. You can check that and do it. So means like yeah. So let me define the same set like this. Yeah. So based upon these things, what I can do, these things which have underscores on either side, if I check, so things which have so contains we can use or in operator. In operator is the most common thing, and similarly, I showed you set is a mutable object. Is a mutable object. What do you mean by mutability? If any object supports in place changes, that is called as a mutability, right? So if you want to add a value to a set, so if I have a set, this simple set, right? Simple set. Uh, if you want to add a value to your set, so you can use the add. If I say like 1 1, and after that if I say hey, what is simple set, you can see that. So you have already a value called as 11. So that's why you added. So adding the element, same element, right? As in it. But if I try to add something like, simple set dot add of, simple set dot add of, say 44. Do we have 44 now in it? No. If I add 44 now, you can notice that 44 is coming. So add is there. So similarly, if I want to, what I have done in a list, right? In a list we have append and extend. So like that, I try to add one more thing. So like I take a list of say 55 and 66. What is saying? Hey, interesting thing. This is the next important thing that you need to understand. Till now, you have created a list tuples, fine, right? And what are the elements that you created in a list or a set? So you are not bothered how many elements are there, whether there are duplicates or not. You're nothing bothered, right? Whereas when you're coming to the sets, next important thing that you need to learn is it cannot store mutable objects. So there are two statements you need to be understanding. Sets are mutable, but can't store mutable objects. This is very crazy, interesting. What do you mean by mutable object? So any object which supports place changes on themselves. Like list, set also does. So we can add and modify and everything, right? Within the same object. And dictionary is one more thing. So these are like mutable objects. So a set cannot store a list or a set or a dictionary. So that's why it is saying that I cannot store this one. Rather, if you take the same thing, a tuple, which is an immutable, right? Maybe like you can convert that to a tuple. If I convert that to a tuple and then ask, hey, what is the simple list? You can notice that it is taking. it is taking. But of course here order doesn't matter, but it will take whatever you give in the thing. Same like list append, but the only extra point is we can't store mutable objects. But so what if I give a tuple, directly a tuple? So I can say tuple of 77. Hope you remember, if you have a tuple with a single element, you should place comma at the end, right? I did the same. See, whatever I placed as it is going right into the same dimension. Similarly, so can I add like a set to a set? That's a most interesting point. So if I say like 88, 99, I have a set which I'm trying to pass to a set. I told like set is a mutable object, so we cannot pass a set to a set. Then what if you want to pass a set to another set? So there is one more built-in function called as frozen set. So frozen set is another built-in function. If you pass that, it is same like a set, like an immutable set. Means as the name says, frozen means you cannot change it. So what is it? Perhaps we forgot a comma. Okay, no, frozen set. We need to use a brace, right? Oh, sorry. You see now, you got a frozen set added. So frozen set is same like your set. So if I say like print off. So two things. Type of simple set and the values, right? If you want to print simple set, and simply I will create like so fz set. If I create fz set equal to frozen set of something, you give like directly, maybe like the same things, 1122 something. All rules of things will be same, but the only difference is we cannot pass as it is. Means you cannot edit it afterwards. So type of fz set, and if I say like fz set, you can notice see here. So first one is like ordinary set, you have the values. Second one is frozen set and its values. So if you see the frozen set, so frozen set is like same like the ordinary set. If I say like print off, so dir of your ordinary set, which is like simple set, which you have seen till now. This would be the typical simple set, which is having all these attributes. Similarly, if I go for dir of say this frozen set, right? Fz set, if I create it, as it is a frozen set, you can notice the differences. So if you ignore things which are underscores on either side, did you see that the ordinary set has add, clear, copy, all these things, right? Whereas in a frozen set, you don't have all those options. Means anything which is changing or updating the existing set were not there, right? But others were there. Now we understood there are two types of sets and doing. And coming back to where we started in these attributes, we have gone with set simple set dot add. Add is working very interestingly. So whatever you give as it is, it will pass, except that you should not pass a mutable objects. In the same fashion, we have one more thing so called as update. Update is also another way of doing. It is similar to list dot extend. Hope you remember list dot extend is there. So like that it will work. So for this, if you pass like a individual elements, it's gonna throw it. If I say individual elements, so what to say? It will take only iterable objects. What do you mean by iterable objects? Iterable objects means objects that support for loop on them. Means string and like collections. Collections means so list, tuple, set, dict, set, dict, and after that we told like iterators, generators. So you don't know about them. Slowly you will learn about them. But you can use any of them, but you cannot pass individually. So I can take it. And you remember We cannot pass a list that we already seen. So what we can do, we can pass a tuple. So we can pass like a tuple. Tuple means if you have a single element, we should pass like a comma at the end. Hope you remember. So if I pass simple set now, did you see that 88 came to the same dimension? Means though it takes like the iterable objects, but it adds to the same dimension. Say like I cannot take like a set, but I can take a frozen set, right? Say I took oh, let me take a list also. I forgot to tell. So an add doesn't take a list, but a update will take, because it won't add directly. It can do it. I forgot to mention this. So say 88, 99, 0. If I have, and if I try to do simple set, did you notice that it is adding? Though 88, 99, 0 you gave, so it is spreading to the main dimension. So simple update is like a taking the elements and doing a for loop and doing an add operation. Like that only you should imagine. Hope it's fine. But way between, like if it has something which is immutable, means outside it is a list, okay. Inside if you have a list, that's where the problem comes. If you have something like this, then it will throw an error. So these individual elements should be immutables. 88 is immutable, 99 is immutable, but this is a list, right, which is not immutable. So that is also you should think. So now you understood two types of attribute things are there for adding the elements. In a list we have a order. That's the reason we can say first, last, middle, somewhere. But sets don't have an order, right? That's why we can use just add and update. It will add somewhere, that's it. So but like it won't do anywhere else outside. In the same fashion, we have seen how to add the elements. Then how do you want to remove the elements from a set? If you want to remove the elements from a set, there are three ways. One, using the pop, two, using dot remove, and three, using dot set, discard, sorry. What are these? How they will work? Let me see. If I take a simple set again, so what are the values means it has some things. Now, if I say the simple set dot pop, hope you remember pop will do so randomly remove. So we will randomly delete values. Why? Because if you see the list, so list if you do dot pop, by default it will remove the last element. But if you give any specific position, it will try to remove the element at that position. But with pop, as it don't have a specific index, it will remove the values in random. So it removed 0. So somewhere 0 is there here, it removed it. So, and if I say like again simple set dot pop, it will remove one more element, so somewhere in random. Now after that, if I ask, hey, what is simple set, you can notice the values. So it will remove something in random. So, and similarly, there is other way of removing is called as a remove and a discard. This is very interesting. Pop will remove any element in random. If the set is empty, it will throw an error. So that is also one point you need to remember. And similarly, remove means removing by specific element. Of course, sets don't have any number of twice. So nothing to do from left or right direction, right? What you do in the list and strings. Like that we need not have. One element will be present only once. Either it is present or not. That's the only point. If I take simple set dot remove of, say I'm going with 88. I want to remove the element 88. It will remove. And after that, if you print, did you see 88 is not present? Okay. If this time, if I try to remove some other element, it will remove that. But what if I asking an element which is already removed, means it's no more there, right? Then it will throw an error. Means remove will remove an element if it is present. If not, it will throw an error. Similarly, there is one more thing. In some cases, if you want to remove an element, but if it is not there also, you should not throw in error. You should just keep calm. So then you can use discard. If you are trying to remove an element which is not present, using discard, it will not doing anything. If you are trying to remove something which is already present, then it will remove. Let's say 44 I give. You see, it will delete that element, and in the output you can't see. Hope it's clear. So this is how you add the elements and remove the elements from a set. After doing this thing, there are last two things. So hope you remember when you're going with a list also, I told about copy and deep copy, right? Copy and deep copy. So every mutable object has this problem. When you want to carefully take a copy of something, we need to go for copy. So for copying a list, okay, the copy set, if I take simple set dot copy, so either like this or so copy module, right? We have copy dot copy. So in both the ways we can do it. If I take now, if you see, I will take the address location of simple set and like simple set values. Similarly, address location of copy set. One second, sorry. You can see when I'm taking a copy, this is how it happens, right? This is why we need to have a copy. Hope you remember I told we cannot just assign like so like in integers. We cannot say like so copy list equal to like this directly. So this kind of assignment if you do, let's say if I am not doing dot copy, then what will happen? So when you are assigning, both will create the same object, right? So what is the problem? If you change one of them, others also will get affected. To avoid that, what we need to do? We need to do in a safe way using the copy method. So for that only I told like why we need to use so this copy. So after that, if you make any changes to it, so it will not have any issues. So assignment is like, so try copy and deep copy with multiple dimensions. So dimensions and check. Hope you remember like copy module, using copy module as we did in list. So that is assignment for you. And the last option so is that dot clear. If I use a clear, then like the address location won't change. If you see the address location and the values, it will be the same. Whatever is for the simple set, same thing you will have. The address location is not changed, but only the values were removed. That is about clear. And if you want to delete, so as I told you, del is a built-in function, sorry, operator, which is very powerful. It can delete anything. After deleting, if you ask, hey, so do you have something called a simple set? It says, I don't know. So that is how it works. Now, till now, you understood about the basic sets and how they will work. And the next point is about the set operations. So this is the most important thing. Set operations were like, what is the mean by set operations? Similar to what you did now, but in a very interesting way. Hope you remember Venn diagrams. In Venn diagrams, we generally like understand many things. So like that, let's take sets. I have two sets called as rainbow. Rainbow means VBGR colors, right? And similarly, I have light, traffic lights. So I made like white also as a light. So just bear me. Just to make a good example, I made it. And if I print them, I defined both of all of them in flower braces. So if I print them also, you can see two sets, the corresponding values. Now there are two things I want to check. For any two, we can relate like super and subset relation. Superset and subset are two things. So under superset means is something in the superior, and subset is like a inferior. If I say something is a superset to another or a subset to another, so what I'm trying to say, traffic lights is a subset of rainbow. Means all elements of traffic light are present in rainbow. If I check now, You do see it is saying false. Is all elements of this present in the others? No. There is a white color which is not present, right? So white is missing in rainbow. Yes. So everything is present. See, in the same fashion, the same question I can ask in the other way. If I take like, rainbow dot superset, means asking the same question in a reverse way. If you want to ask, means rainbow dot is superset, means rainbow should contain all the values in the traffic light set. That is what superset means. So that is also not possible because white is not there, right? The same thing you asked in a reverse direction. So if I go with like uh, another set called as alphabets. For the alphabets also, I can ask the same two questions again. So whether like something is present within it or not. Only if all the elements of one are present in another, we can get that as true. In this case, nothing is common. So in this case also, it will say false only for both of them. Then going further, if something is like having not even a single value common. In that case, we can call them as disjoint. You see, traffic lights and rainbow has at least some colors which are common, right? Red, yellow, green, these were common. Only one of them is missing. If that is also present, we can say subset and superset relation. As that is not there, fine. So, but for alphabets, nothing is common, right? So for that, we can say is disjoint. Disjoint means what? Both are not at all related. There is not even a single thing which is common. So if you want to check whether something is common between two, so for that we need to use intersection. Intersection is another operation we need to use if you want to get common things between two sets. So between traffic lights and rainbow, we have something common that you found it. Similarly, so if I do the same thing with these things, you can notice the for the alphabets, right? So let me do all in one shot. If I place like this, you see everything. Yeah. So for traffic lights dot is disjoint of rainbow, traffic lights dot intersection. Similarly, alphabets is disjoint. Yes. If something is disjoint, then the intersection will be true. So nothing. So the intersection will be empty if it is disjoint. If it is not disjoint, at least one of them will be there. So now you understood about this point. Next, you know, till now we used plus operator with almost all data types we learned till now, right? So you have added two tuples, two sets we are two lists we added like that. But we cannot add two sets. Sets cannot be added because there is that is not possible. So sets if you're trying to add, it will throw an error, that unsupported operation. So plus operator is literally supported by almost all except plus. But so set support minus operation. That is very interesting. What do you mean by minus means? That is called a set difference. If you want to understand what are the set differences and set subtractions and all these things, you need to go with Venn diagrams. Venn diagrams are a better way for you to understand that.
Uday, we cannot listen to you.
Oh, sorry. Okay. Oh, sorry. As I showed in the Venn diagram, we can check so any of the differences. So first you understood about what are the common elements called as intersection. If nothing is common, we call it as disjoint. If there is something common, you will see that. And what are the common elements if you want to delete? That is called as set difference. From whom you will delete? From the first set, you remove the common elements between first and second one. So you will get the remaining values from the first set. So remaining values from the first set after removing the common. But what if you want to get both of them together? So that is called as union. If I do union, I will get all elements in both of them. That's why union operation is commutative. Either you go so A union B or B union A,